Good morning, geometry students. I hope you're doing awesome. I am very glad that I'm here working with you again. We are going to be doing another lesson in Chapter 5. Now, I know this might be a little bit stressful for you because we are doing proofs in Chapter 5, but I wanted to encourage you that I'm going to do everything I possibly can to make it easier for you. One of the ways in which Chapter 5 can be a little bit more straightforward is if you have your two documents called 5 Steps to Doing a Proof, and then also the one that says Word Bank for all of Chapter 5 proofs, because that will give you step-by-step instructions on how to set up each proof, and it will also tell you basically all the possible words that you might need to use in a proof. So if you have those two documents out while we're doing notes as well as while you're doing homework or during Zoom sessions, it will make it a little bit easier for you. Okay, so we did lesson 5.1, and that was just more an introduction to general polygons. What does it mean for two polygons to be congruent? Can you remember what it means for two polygons to be congruent? It means that all corresponding parts of those polygons are congruent. So all the corresponding angles are, and all the corresponding sides are. So then in the lesson that we talked about last time, it was more specifically targeted towards triangles, and that's what we'll be focusing on the rest of this unit is congruent triangles. So we learned about how the corresponding parts of congruent triangles are congruent, and we also learned about something called the third angle theorem. We also introduced the word reflexive property, which means that something is congruent to itself. So today we're going to learn about one theorem, and then I'm going to do two examples with you that illustrate the use of that theorem. So let's go ahead and talk about, I'm just going to read you the paragraph that we would normally have a student read in class at the top of the handout notes. In order for two triangles to be congruent, we know that all three pairs of corresponding angles, and you don't have to write any of this down, don't worry, I'm just kind of giving you the background, and all three pairs of corresponding sides need to be congruent. However, it's possible to prove two triangles congruent using fewer pairs. Mathematicians have developed several theorems that allow us to do so. Today we will learn the first of these theorems, side, angle, side. So let's write down the word theorem, and then underneath it we're going to write side, angle, side. That is the name of the theorem. The thing I love about the proofs in Chapter 5 is they are exactly what they sound like. Side, angle, side. All right, so let's do a picture of what the side, angle, side theorem looks like. I'm going to do two triangles here that are going to end up being congruent to each other. And I think I'll go ahead and label these. Let's label the first triangle A, B, C, and then the second one D, E, F. A, B, C, and D, E, F. Now I'm going to read out loud to you the definition. You don't need to write that down, but then we will mark up the triangle to demonstrate it. So this is basically a shortcut for us, because we know if I can show you that all three corresponding angles are the same size and all three corresponding sides are the same size, we know that the two triangles are congruent, but that's 6 different things we have to prove. So mathematicians have developed shortcuts where we only have to prove 3 things, so that is half the number of steps. So here's what the theorem says. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So that is kind of a mouthful. Let's draw a picture of it. I want you to mark up on this triangle 1 hash mark here and 2 there. And again, you should be watching this on some kind of device that allows you to zoom, an iPhone, an iPad, a MacBook, and an Android phone that allows you to zoom. And then we're going to do the same marks on the other triangle. So what that's telling us is that segment BC, I'll highlighted that in green, is congruent to segment EF over here. their corresponding sides, okay? And then we also know from how it's marked up, I'll use a different color, that segment AC is congruent to FD. So notice that we've pointed out two pairs of corresponding sides that are congruent. The included angle is going to be the one formed by those two sides. Do you see how angle C is formed by the green segment and the pink one? So that would be the included angle, the one formed by the sides. And then on the other triangle, angle F is formed by those two sides. So if we are given two corresponding sides that are congruent, then the included angle as well is congruent, then we are allowed to conclude that the triangles themselves are also congruent. Now, I have some examples that I might normally go over in the notes of how to see examples of that. We will do that in the Zoom session. What I thought would be the best use of our time today, because I know that you have a lot of computer time as it is already, is just to do two examples of proofs with you using side angle side. So what we're going to do is draw a diagram here. So I'm going to draw, this is a shape actually called a parallelogram. I'm going to draw that shape there with the diagonal going through it. And then let's label the vertices A, B, C, and D. Again, feel free to pause this video as you need to go ahead and make it easier for you to copy material down. Okay, so this is the figure that I've been given. And we're supposed to prove that the two triangles shown are congruent. Let's write down the information that they are giving us in the given. The information given is that BC is congruent to DA. Notice that we already knew that because of this hash mark here. BC is congruent to DA, but we're writing it and showing it visually. Also, we're given that BC is parallel to AD. BC is parallel to AD. We also know that from our figure because of the triangles here, okay? Then the statement says next, prove that triangle ABC is congruent to triangle CDA. Now, what I would like you to do, if you have this printed out, is look at your 5 steps to writing a proof and see what the first step is. The first step is to draw a T. So I always tell students who say, oh, I just can't do proofs, I say, can you write the letter T? And if they say yes, then I tell them, then you can start a proof. That's it, writing the letter T. We've now started our proof. That's step 1. Step 2 is to write the word statements here and reasons here. So every single time, 100% of the time you do proofs, that's your second step. Everybody can remember that. Now, step 3, do you remember what step 3 is from before? Step 3 is to write whatever you've been given. So this information here that I've been given, I need to copy down into the proof. So again, we're not having to think about anything really, we're just copying information. So we're gonna write segment BC is congruent to segment DA, and then we're also gonna write that BC is parallel to AD. And then the reason is going to be given. 100% of the time, our first reason is going to be given. Now the next thing we need to do is copy down whatever the information we're supposed to prove is. I always put a 10 for that statement number because I don't know yet how many statements I'm going to have, and then I can fix it later. We want to prove that triangle ABC is congruent to triangle CDA. Okay. Now, the very last step says to look at your picture and see if there's any information that you can tell from what you've been given. So the first thing I want to do is, and sometimes colors can help in geometry, is I want to draw the parallel lines in a different color. So we have two parallel lines here, crossed by a transversal. And now what we want to do is draw on something that we learned before. Who can remember when two parallel lines are crossed by a transversal? This is lesson 3.2, so from chapter 3. What do we know about the alternate interior angles? See if you can remember that. What do we know about the alternate interior angles? If you said they're congruent, you are right. So this angle right here and this angle right here would be congruent to each other. Now I can't just say C is congruent to A, because there's actually three angles that have C as a vertex and three angles that have A for a vertex. So we have to be very specific. We have to say, for our second step, angle, and I'm going to go BCA. So angle BCA is congruent to angle DAC. DAC. And for the reason, we just say alternate interior angles are congruent. Now, if you weren't sure, you could look at the word bank. And in the word bank, it's going to say ways to prove that two angles are congruent, and one of the options would be alternate interior angles are congruent. Good, so now we have an angle down, which is good. Now we're looking for side angle side here. We have a side and an angle on this triangle, and a side and an angle on this triangle. We need one more side. And this is a word that we briefly introduced in our last notes. It's the word reflexive property. So let me show you how we can use that. We can write that segment AC is congruent to AC. This segment here is congruent to itself, and I'll put two tick marks there. The reason is going to be reflexive property. And you can find this in your word bank also for ways to prove that segments are congruent. Now notice that we have a side, an angle, and a side on this triangle, and a side, angle, side on the other triangle. And so we've got two pairs of congruent sides, and the included angle that they form is also congruent. So based on that, we know that the triangles themselves are congruent. So we're going to change our 10 to a 4, and for our reason, we're going to write side, angle, side. Side, angle, side. So I know that was a lot of work. That's why I'm only doing 2 examples. If we were in class, we would have written notes to work with, and we'd be able to ask questions back and forth. And so obviously, that we'd have a lot more options for ways to get clarity on this topic. So I'm going to try to just streamline things as much as possible as I can for you guys to make it less stressful. So we're going to do one more example. And for this one, we also need to have a picture. So we're going to do this kind of a shape here. And I'm going to label the points E, F, G, H, and I. E, F, G, H, and I. Our given is going to be that G is the midpoint of FH and EI. So G is the midpoint of FH and EI. And then it says prove that triangle GFE is congruent to triangle GHI. Now this is somewhat daunting because if we look at this, there's nothing marked up on the picture. That often happens in proofs. It doesn't mean we don't have any information. It just means it hasn't been drawn on the picture for you. So we're going to draw that. Let's look at the information we've been given. G is the midpoint of FH. Does anybody remember where the midpoint is on a segment? Where is the midpoint on a segment? It's right in the middle, right? So if G is right in the middle of FH, it means that this segment here is exactly the same length as that segment there. We also know that G is the midpoint of EI. So this piece here is congruent to this piece there. So whether we realize it or not, we actually already had two pairs of corresponding sides that were congruent based on the given that we had. So let's go ahead and write that out in written form instead of just verbal. Remember, the first step to writing our proof is to drawing the letter T. So we're drawing a lowercase t, a big one, on our paper. Then the second step is to write the word statements in the first column, and then reasons in the second column. Can anyone remember what my first statement has to be? What does my first statement have to be? My first statement is whatever I was given. So I'm going to write that down. I'm going to say G is the midpoint of FH and EI. G is the midpoint of FH and EI. And my reason is what? Given. Given. Good. All right, now we are going to verbalize formally what we talked about on the board a minute ago. I'm going to write down that FG is congruent to HG. In other words, from F to G is the same length as from, let's see here, let me make sure I'm right, H to G. Now, does anyone remember how we knew that? How did we know that the length from F to G was the same as the length from H to G? It was because they told us that G was a midpoint. So if you look in your word bank, you can see the reason is definition of midpoint. That is the definition of a midpoint, that it cuts a segment into two congruent halves, or that it runs right down the middle. For that same reason, we can also say that EG is congruent to IG. So we don't actually have to write two separate statements. We can put all of that information here and use the same reason for both. Now, we're trying to prove these triangles are congruent using side angle side. Notice that we have two pairs of sides. Does anybody know how it is I know that these two angles are congruent? And I'll write down the statement, see if you can think about the reason. I'm going to write that angle FGE is congruent to angle IGH. Angle FGE, so FGE is congruent to IGH. And let's go ahead and mark that up maybe in pink here. How is it that I know that those two angles are congruent? Starts with the letter V. Look in your word bank. The reason is that vertical angles are congruent. Vertical angles are congruent. So now I have enough information to prove what I'm going to prove. And by the way, I could have written down this earlier and put the 10 there and now erased it and put a 4. I didn't. You don't have to put that there in the beginning. I encourage students to, just so they don't forget, especially on a test. But we can now say what we're trying to prove. That's the statement up here, that triangle GFE is congruent to triangle GHI. And the reason is going to be side angle side, because I have two sides and an included angle. Awesome job, you guys. Can't wait to see you in Zoom. Okay, bye.